Hi, so I'm really interested to present here in this context of applied computer science, and I'm really curious what feedback you have for me later or questions. So I thought I would start by showing you some previous work that I did with data visualization, and then move to some more recent work in my PhD, which has moved from data into like visualizing computation and algorithms, hopefully. So being part way through a design research PhD, that's also kind of part theoretical, part practice. There's some kind of overarching things I'm trying to look at. One is sort of how to work at the intersection of the sciences and the arts. And for me, the sciences have sort of started with the biological sciences, and now it's moving toward the computer science. And so I'm trying to, so I don't have a science background or training, but I'm trying to kind of bring sort of arts research and the knowledge that we might conceive of in the arts to bear on more abstract, complex ideas. So my work is in part about visualizing computation, and then another part is critiquing computation, so putting computation into a social and political and aesthetic context. And then the third part is trying to look at the history of reflexivity in different mediums like cinema and literature, and then what does that mean for computation today? So I thought I'd start with when I first started working with data and first started using code to develop projects. So several years ago, I was in London and I was studying this site in the Thames River estuary, so just outside of London, a site called Two Tree Island, and it's a naturally formed salt marsh. And so salt marshes, if you don't know, it's kind of a natural coastal formation, and they're declining in the UK at least. I think they are here too. It's kind of a global warming problem. And so after reading sort of some of the literature around this issue, this problem, I understood that there was all sorts of theories on why they're declining, but sort of not an overarching agreement. And so I was interested in the fact that this was a kind of contentious site in a way. And also I was interested in how environmentally salt marshes for me appeared to occupied a kind of like interstitial zone between the sea and the land, and then the kind of ugly but they're sort of very ecologically productive, but then not productive according to a capitalist logic. So there's this sort of like post-human idea to them. And so I set about creating these 3 registers of the site, or surveys. So the first being a biochemical survey, the second being a LiDAR scan or laser survey, and then the third was a cinematic. And so this also gives me an opportunity to collaborate with these different disciplines or expert groups, which for me is kind of part of the aim as well of doing this type of work. So I started with a biochemical survey, as I called it. So working with scientists from University College London and University of East London, we conducted a survey of this site, collecting data like dissolved oxygen, pH levels, conductivity, and then GPS data. So what you might call the kind of biological tests that kind of indicate a sort of general health of a marine or coastal environment, which relates to the availability of nutrients at those sites. And then using processing, I would visualize these sites across kind of a georeference map of the site. And because the salt marsh has a very specific physical morphology that's generated both by the physical tides and then by the biology of the site, my task was to experiment with how to visualize sort of the patterns between this physical morphology of the site and then the biological data that we collected, which kind of didn't necessarily match. And so I experimented with various things, but one visualization I ended up with was using a sine wave field to express the kind of chemical intensity and express it spatially in this sense, in relation to the channels in the terrain. And so that's what was of interest in working with these scientists that I was consulting with. And then the different sine wave fields were overlaid to compare and contrast them. And then this is a kind of animation to show, you know, how using the sine wave field to visualize intensity spatially, how it kind of worked, how different things would grow at different rates. And then as a design speculation, my proposition was sort of that this micro species called a diatom, you know, has the potential of a kind of architectural scale consequence for this post-human landscape. So then, as a second survey, consulting with a kind of different group who would have a different perspective and stake in this site. I worked with LiDAR data to create a physical scan, albeit of this very unstable terrain. So I originally I wanted to create my own LiDAR scan of the site because I wanted to work with a more human scale perspective, but I had to settle for data that had already been created and was available through like the UK's like government geomatics department, so I could just buy the data, and then ended up with this kind of aerial satellite perspective instead. So for me, this was a diverging way of looking at the same site, where using a different technology affords a different understanding or an even valuation of that site. For example, in contrast to the biochemical data. So with this data set, it collects kind of precise 3D measurements that then can be made into an accurate topographic model. And this data set is associated with land demarcation and its valuation. But for me, it was kind of arbitrary to find data like this for this site because the site itself is so unstable and usually considered to have no capital value. And then the third register was what I would call a cinematic survey. So I worked with a film crew and we shot a classic tracking shot of this eroding boundary line of the salt marsh. And so I conceived it as a cinematic survey to kind of accompany these other surveys using chemistry and laser scanning. But one in which we might say we're valuing the aesthetic or contemplative value of the site. So in film theory, a tracking shot, kind of coming from the history of the panorama, it's also a tactic of capture and sort of quantification in its own way. And that has its own kind of way of creating value through the image. So here you can see that this terrain is very wet, unstable, rough, and yet the image sort of glides through it very in a kind of unhindered way. And on the one hand, the image seems stable and coherent, but it's also still a very artificial view as well, and subjective. And ultimately, some of this work was made into an installation, a video installation, which I called like a video escape at the time. And so this is a kind of mock-up of how I was imagining an installation, although this is a bit more far-reaching than I ended up. At the time, I wasn't aware of things like shaders, so I think I was like maxing out the processing power of processing at the time, because we're trying to have so many videos in the same animation. And then something else I worked on shortly after that, I called it nanoscanning, and it was a design competition, a kind of visualization challenge. And for me, it was a design speculation that kind of had its starting point in a more traditional techniques of science visualization, and even you could say medical illustration, in that this is specifically a HIV molecule that's being visualized. And I developed a custom applet in processing that just kind of redrew the structure, like the geometry of the molecule, but I tried to do it in a kind of sort of generative way using agents. So at the time I was looking at all of the science visualization work that was going on at the time, and it all felt a bit kind of, just very straightforward and literal, and I was trying to come up with another aesthetic technique for it. So the workflow for something like this was starting in 3D Max and creating initial kind of models of this molecule and different, like a beauty pass, ambient occlusion, depth pass, to create a point cloud of this model that was created out of agents kind of retracing I was kind of describing it more analogously, like the agents tracing the geometry of the data. What was interesting for me about this project was that it was the first time that I used the Control P5 library in processing, and realized that I had this access, or I had this ability now to make my own software, and I'll buy mini pieces of software, but I could then give that to somebody else, and they could interact with it, and they could use my tool to make their own visualization out of this system. And so I feel like that opened up a lot of possibilities for me, coming from the arts, starting to work with code in projects, and then kind of having this new. So this is an animation of that project I was talking about. But I think that that's at the heart, perhaps, of some of the work that I'm trying to do, and I think it's very much an affordance of processing, the processing platform, and the programming language, and the effect that I think it's had on a lot of artists and designers. So I feel like processing as a platform has been really transformative. And for instance, I wasn't a young person or a teenager who was coding at home. I only came to this kind of work as an adult. And yet it was processing that I feel like that has afforded artists across the board to be able to kind of conceive of building custom tools, prototypes, and in a way it's that platform that's enabled the arts to kind of push up against computer science, which I consider to be a pretty important literacy today, in order to be able to tackle the issues of the day. So another piece that I created, that this was for an exhibition here in LA, and I started working with a new technique that at the time I was calling cinematic visualization. And so this combines filmic views of a site in Death Valley in California with the simulation of flash floods that occur there every year or every few years. And I think I was initially just captivated by this idea that you could have a desert and at the same time it would flood. And that seemed like kind of aesthetic or sensual to me. So these scenes took their starting point from a research paper by Noah Schneider and Lisa Kamler. And it was published in the journal Geology, and it's called Dynamic Adjustments in Channel Width in Response to a Forced Diversion, Gower Gulch, Death Valley National Park. And so Gower Gulch is a small site within Death Valley, and it's a narrow, winding channel. And it was created through an artificial diversion of a bigger desert wash that took place in 1941. And what the research scientists would say about this is that it uncovers this expedited view of geological change that would otherwise have taken like thousands of years to be able to see, but in this case enabled them to see change in just a few decades because of like the particular nature of the sediment there and the particular nature of these kind of artificial flash floods being diverted. So in terms of design, it's kind of a hybrid combination of film and then these digitally produced simulations. And the simulations were created from the data that's in the paper, kind of measurements of the changes that they mapped over time. So it combines, so it's not actually coded, these simulations. I started working in a different software called Houdini, and because I was interested in this, it's really, Houdini's really powerful for creating particle simulations. And so I started combining kind of models with these particle simulations and then using camera matching techniques to kind of simulate, to kind of sync them with this more like filmed landscape or cinematic views. And I think what I was trying to do with this, like starting with the research paper and then developing this particle animation, was show like the phenomenon of these floods in the desert and then their kind of geomorphological consequences beyond the human scale of perceptions. So trying to think of like a geological scale of perception. And this is another project that it's a visualization that uses nitrogen and phosphorus levels of the LA River here and here. And it's actually a piece that has a voiceover on it, but I just silenced it and I'm gonna just talk over it. But this was also for a design competition, and that was organized by the USGS and the EPA here, and they wanted people to like go into their repositories of data and create visualizations from their repositories. And I guess it was an attempt to kind of publicize the fact that there's these vast quantities of data publicly accessible that people maybe don't realize that they can use. So the visualization provides this, it's supposed to provide this overview of the available public data, sort of its seasonal, geographic, and annual scope, and then also its limitations. And for me, what I found was that I collected all of the publicly available data, and then I found that there was these other groups that had done testing on the river. So there's a non-profit group called the Friends of the LA River that had acquired a lot of data, and then there's another citizen science project. And what I found was that it was these other groups that had actually done the most comprehensive study of the river and not the data that was available from the USGS or the EPA. And so in a way, my visualization and with the voiceover is also making an argument for kind of maybe a case for sort of greater community engagement and kind of water testing and this sort of more distributed approach to restoring the river. So design-wise, it starts off with a digital elevation model, and then that's georeferenced and visualized. I don't think I can go back in this. Anyway, and then you can see these nitrogen and phosphorus levels kind of growing across time. And so the data's kind of visualized spatially over time, and then georeferenced. And then I wanted to contrast it with these shots of this drone footage of the site to provide a local visual reference to this data abstraction that you get to see. And when I was doing this a couple of years ago, I'm not exactly sure where the LA River is now, where it sits now, but at the time, the LA River was sort of on the cusp of getting this huge, like $1 billion federal money to regenerate it. And they were trying to, the aim was to kind of dig up all of the concrete and turn it back into a natural river that has vegetation and animals and recreation, rather than these kind of weird canals that are kind of like no man's land spaces and sort of cut off from the city. So in a way, the project was done in the context of like what the river could become. And then I started, I wouldn't say I was still working with data at this point, but I started working with the technique of photogrammetry. And I didn't know a lot about computer vision at this point, but I kind of knew that computer vision was sort of interesting. It was sort of like at the center of this intersection between kind of human perception and computer perception, and like where those correlate and where they diverge. So I created this piece also for an exhibition that tried to kind of hybridize these sort of traditional representation and then this new kind of mixed reality point cloud kind of space. And I was interested in how, for me at that point clouds and photogrammetry and LiDAR and depth sensors, including things like Connect and the RGB toolkit, I felt like all these things were moving us from these techniques being kind of advanced sciences in the remote sensing field into kind of becoming very accessible, like DIY techniques that we could use for creative and exploration. And so I started filming sites around LA with like a consumer drone, and then I had the idea that I was going to create these point cloud models from those using photogrammetry. And then I crashed my drone and broke it, and so I had to kind of downscale and work with like smaller scale models, like of bridges here and like parts of the LA River Basin, for instance. That I used the data just from video that I had to capture myself. And I was interested in how for instance, the point cloud was enabling us, or was maybe like replacing the image in culture, in the way we think about design and the arts. So for instance, where like we think of an image was this 2D array of pixels, and now an image, what we think of as an image, is becoming this 3D array that has RGB data, and now it has an X, Y, and a Z dimension. So this Z dimension seemed to become really important. And like reconceiving images as, instead of, like we said, like flat 2D arrays, but rethinking them as computational, scalable, and immersive. So where you could choose to just look at something as a 2D view, but then you always have the option of the 3D view, and then you can also stand inside of it as well. So at the time I was following people's work like ScanLab, who actually talk about the LiDAR device as being like the 21st century camera now, because of its kind of incredible resolution and the fact that it has like storytelling capability in a way. And then I was looking at projects from, say, a design group called Marshmallow Laserfest, they did a VR project called In the Eyes of the Animals, which was like a post-human take on experiencing the forest from alternative species perspectives. So you could kind of navigate through the forest as like a grasshopper or a bird, for example, or something like that too. And I was also thinking about Ben Grosser has a project called Computers Watching Movies, sort of like visualizing what's going on in the algorithm as an algorithm might watch an image or a film. So it felt to me like there was this trend coming out that was seeking to kind of create and speculate on these alternative perspectives to the human perspective. And then these technologies were at the same time affording us these explorations. So here's a couple of animations of stuff that came out of this using the photogrammetry workflow. But then I wanted to kind of reflexively compare what you would say is the output, which is the point cloud, with the input, which is the video image. And then here's another version of that where I remapped like the original camera positions that created the data sets for the photogrammetry workflow, and then animated their camera motion to kind of try and reflexively show the images that we used to kind of compute the point cloud. And then in the exhibition there was 3 screens, and the third screen was a kind of interactive walkthrough of the point cloud, which I generated in Unity. And then more recently, I've tried to move from working with sort of like fixed data sets that are, I don't know, like some kind of real world measurement of some kind of phenomenon, whether it was like biological or just spatial. And then thinking about like what are the computational processes at work in how we visualize these things, how we visualize this data. And so I started this study that was trying to take what I would consider quite an advanced technology, in this case like a surveillance camera, for example, that kind of is very much rooted in a sort of maybe social and political space, maybe kind of controversial, like surveillance images, and then trying to sort of like backtrack or trace back and the algorithm that's maybe at the heart of that. And I wanted to do it visually. So working back, from, in this case, it was cellular automata that I looked at, and the kind of like that sort of like state change logic, and then through how that logic continues through image processing techniques, and then onto computer vision, and ultimately how you recognize objects in a surveillance camera. So it's kind of an attempt to like reverse engineer a cultural issue, in this case surveillance, back to a particular algorithm, in this case it's the CA, and sort of to do that with a kind of visual design process, a visual language. So I chose the cellular automata algorithm, first of all because they use a grid system, so they have an affinity to like images and 2D arrays, and also because they're very visual already. So I was trying to draw the line visually between this very simple computational logic and its visualization through kind of a more advanced technology with like cultural issues around it. So if maybe I was going to say, at the time I was also looking at this new field that's called software studies, you might have heard of, right? Where the call, I think originally by Lev Manovich, was sort of for the arts to turn toward computer science and to try and understand this new cultural composite between kind of human and machine meaning. And so I saw that as a sort of reflexive thinking around some of these ideas. And one aspect of software studies is this field called critical code studies. And so I work in a lab at USC called the Critical Code Studies Lab, but maybe I'll talk about that a little bit later in relation to another project. So this animation on the left-hand side is called a Langton's ant, and it's a version of a CA where instead of every cell in the grid changing state in every frame, just one cell is changing state, and so it kind of creates this kind of like snaking effect in a way. Or you have to maybe stop. Maybe I'll go back. Oh, there we go. And so what I did was apply. First of all, I'm kind of like just thinking through the problem visually for me, but so I tried to apply that logic to an image that has content in it, like a photograph, right? So on the right-hand side, this is a lot of these Langton's ants kind of traversing through an image. So you can kind of see that, that's what I'm trying to show. It's like you have the Langton's ant, and then like a lot of these blue and red things are like agents going through the image. And so what I was trying to show was, can you see that? Oh yeah. I have these two visualizations. So one's coming and it's in color, and then this one is black and white. Oh, it's not animating now. There we are. And so what I was trying to show is thinking about computer vision and this, disconnect between the human and the algorithm's way of looking at something or conceiving of something. And so for me, this is when I was looking at and I should say I was using the OpenCV library in processing for some of this. When I was looking at the scripts in that, what was happening is that the way the algorithm reads the image is by simplifying it. So the algorithm in a traditional CA, the algorithm's just looking at red, or is the cell black or is it white? And how many neighbors does it have? And then we change the color. We flip it from black to white. And in this case, the algorithm reads the image according to 4 colors, like a grayscale. And so the agent will say, if I'm going in one direction and I need a cell that's of this particular grayscale, then I'm going to change that direction, and vice versa. And so all I found with these visualizations was that I could feed in an image, and it would kind of, almost like come up with these sort of different patterns would emerge in the image. So this particular image is from it's a satellite image of a view in the Amazon River. I think it's quite a famous view where the 2 rivers meet and they kind of have different colors and they continue. I can't remember. It's part of I think one is the Rio Negro, and then another one. And so this is what we see. So I was trying to kind of visually represent the difference between the way the algorithm kind of works on an image according to these computer vision libraries script, and then the way that sort of we see the results of that image, and those things being different. And then I did a lot of these, and I was also just interested aesthetically in the kind of way the algorithm would kind of, you could say, like re-terraform the land. I mean, I'm talking more metaphorically because they're landscaped images. And then thinking along those same ideas of the way the algorithm, first of all, sort of simplifies the grid of an image and then reads it according to simpler state changes, I was then thinking about how in the computer vision, the OpenCV library, only a few of the scripts or the capabilities in terms of computer vision is the kind of classifiers that actually recognize things. A lot of the work in computer vision is just quite what we're all very familiar with in terms of like image processing techniques, and whilst in this case they're done algorithmically, we're kind of quite used to using these techniques on our own in Photoshop. These different image filters like blur and sharpen, and these are kind of like at the heart of computer vision libraries too. And so I started to try to think through this and how pixels were recognized as being, important for some reason or not. So this is a very simple visualization of, say, you can imagine it's surveillance footage, like from a street camera. And so what the algorithm is doing is simply identifying, is the pixel changing? And if it is, I'm going to make it white. Is the pixel static? And if it is, I'm going to make it black. So it takes in a more complex image and kind of reduces its complexity to just black and white. But then, obviously, to a computer, you can much more easily see, oh, this is something interesting, these kind of objects moving across the screen. This is So I then did my own version of this, where I used a film of the chameleon, which is like, very still, a very still animal, and very ancient animal. And I wanted to use this very contemporary technology to look at it. And so in the top image, you're seeing the algorithm just recognize change. And then in the bottom image, it's kind of printing that change. So just printing back to us the pixels that move. There's something about the fact that the chameleon uses stillness as a form of camouflage, and that motion is the thing that kind of is how it reveals itself to the camera in this case. And then I have like another version of this, which is just a close-up. So of course, at the same time as I was looking at these visual studies and thinking about, like I said, for me, computer vision is a kind of contentious topic, I think, in society. So whilst these particular images are, just of the chameleon or the satellite images of the Earth, but I was at this point thinking about the fact that from another perspective, code, or source code, algorithms are like are texts that have social and political meaning. And so I'm also working in a lab at USC called the Critical Code Studies Lab. It's run by Mark Moreno. And in that, it's kind of coming out of the humanities, or the digital humanities. And in that, we look at source code and we try to kind of read it from different perspectives. So looking at source code from the perspective of gender, looking at source code from the perspective of post-colonial studies, or things like that. And so I was reading about how, I think you've probably all heard these stories in the last couple of years of computer vision, having problems reading different race in people, or different skin colors, and kind of like bringing to the forefront all of these really problematic and ethical positions, which at the time I couldn't kind of like bring them in. I didn't know how to bring them into the work visually, but I was thinking of this, and I was also thinking about, there's a book called Virtual Migration by and Anish, and he talks about this concept of algocracy, which he describes as, it's like a new way of, it's the new position in our lives that the algorithm is taking up. So he calls it like algocracy is the rule of the algorithm, or the rule of code, and it's kind of taking up this very prime position in our lives now. So with this project, I was like trying to start visualize computational processes, but then I moved on to another project that does this a bit more overtly, and am I good for time? Yeah. So this is, most simply put, it's a visualization of machine learning algorithm, and it's one of the most simple machine learning algorithms out there, which is the decision tree classifier. And I started with this because I wanted this entry way into this, very advanced field. And I've started to work with a lab at USC called the Center for Artificial Intelligence and Society, and very just pragmatically, I needed to kind of put something on the table to kind of start this collaboration. So what I was trying to do with this is, so I generated these classifiers myself using Python's scikit-learn library, and I wanted to just simply have a visualization of a classifier. So like, if you imagine what a classifier, the code might look like, so taking that code, it's all developed in Unity as an interactive tool, and kind of like map out an algorithm and then show the data flowing through the algorithm in real time and kind of literally being classified, so being forked and passed off, and then ultimately these kind of bunches that you see is sort of how the algorithms predict, is its predictions. So I have a few different video animations of this. And prior to doing this work, I was looking at design references from the world of programming games. There's this genre of computer game called a programming game, and it's where developers will, I think it's kind of coming from like systems theory, but it's where developers will use concepts from programming and computation to create video games. So for instance, Factorio is a really famous one where you're building a kind of object-oriented approach to building a factory, that has inputs and outputs, and you have to kind of create these small-scale machines that build up into higher-scale machines. And another one that I referenced is called Space Chem, which is a game that visualizes. You kind of play the role of a biochemist or a chemist maybe, and you have to kind of put together different molecules to create higher level atoms, or you have to kind of, it's like a puzzle game, you kind of combine different things, but it creates these, sort of animates like the loops, and then it has something which I would describe as maybe visualizing like a bug in the system. And so I wanted to use some of these ideas in an application like this. So for instance, for me, one of those things, let me go back. So one of those things was just simply animating time. So you could look at something from a very fast emergent time frame to something very slow, where you can see like individual data points flowing through that system. And then another thing, like how to visualize a mistake or a bug, which is something I'll show you in a minute. And I should say that I was using, I think this uses the iris data set, but generally I've been using only synthetic data in these, so the data actually doesn't have any sort of real world meaning to it. It's not situated in a social political context, which is ultimately my aim for this work. Anyway, I'll move on to another one. So it's kind of like experimented with different data sets that would give me different topologies of classifier. Right? Maybe it was like different numbers of features to targets and things like this. And then I think it's this one that, so one of the most productive things I got out of this was that I managed to visualize mistakes, which to me was kind of exciting because we hear in the way that machine learning algorithms are being used in the world today in sort of very contentious applications of them, you hear about mistakes happening. And so this is kind of getting at where I'd like to work, where I'd like this work to go. So I think it zooms in a minute, and I think there was a few questions that I was thinking about with this work, which is, one is kind of just very basically like, is visualization a kind of a-linguistic tool that we could use to re-engage with algorithmic decision making in an area where humans are at risk of being precluded? So maybe that's a question that, I don't know if it's so relevant working with decision trees, but it's something that I'm thinking of working in this space. Because one of the questions I always struggle with is like, what's the audience for the work? And one area I've looked at is, where there are some algorithms that are used where, say for instance, in social work, which is the lab that I'm starting to work with, they kind of have this collaboration with social workers. And one of the problems is that you create an algorithm and you can say, oh, it's, 98% efficient, 98% accurate, but you can't tell them where it's made that mistake or why, even when it's accurately predicting, they can't necessarily pinpoint how that's come about sometimes. And so there's this uncomfortable position for people who are making decisions in maybe key worker roles, like in healthcare or the justice system, that we're starting to see these algorithms in these places, like in the courtroom and in healthcare and the police, and some of those key workers feel uncomfortable about using these algorithms and not really knowing why the algorithm's making that decision for them. So one idea was like maybe a tool like this could kind of fit into that space somehow of like providing some visual understanding. And then another idea for me was just about methodology. So, can in combining like interaction design, generative design, and maybe an approach from critical code studies, like do these combine into a sort of design research methodology that's useful in looking at some of these ideas? And then another question I had was, there's an area that I heard about called bias augmentation. So, for instance, a lot of people, when studying trying to look at algorithms critically, or as part of this working group at USC called the Ethics in Algorithms group. And a lot of people, usually people that don't come from a coding background, will say, oh, the problem's not in the code. The problem's in the way algorithms are situated in a social and political context, the way people use them, the way they misuse them. But then this area of bias augmentation would say, no, there are instances where if you, sometimes there's a very small bias in a data set, and then just through the structure and the process that takes place in the algorithm, that bias is augmented. And so that was something that I would like to look at in the future, is how does that happen if you, so I guess just to summarize my research, like I've come from this data visualization background, and now I'm kind of trying to look at algorithms, like visualize them, but also critique them, and develop tools and visualizations to put them into a more reflexive situation. And I'm especially interested in where they're used in a contentious situation, or maybe even a dangerous way, and trying to visualize that contention is kind of what I'm aiming at, which I haven't really got there yet. But whether that contention could be bias or error, or just the discord between human and algorithmic understanding, or just to express some kind of ethical position. And my task is like, what can we do? How can we use arts research to do that?
We would like to invite you to engage with our presenter. I think there's definitely a lot to unpack here, so looking forward to your questions.
I find it really interesting that when you were talking about your work, you bring up the questions that your work actually, that your work raises to yourself. So I was wondering, because we usually look at many speakers that come from such a research background, so I imagine that's where the connection is. I was wondering if you could elaborate a little bit more on how important these questions are, and how do you approach, like, is it, do you raise questions in the beginning of your work? Is it once it's finished, you go through it, or is it always present? Is part of the whole process?
So I think being partway through a design research PhD, it's it's just pragmatic to always be framing questions and thinking about what the problem is. And but I don't have a science training, so we're not actually kind of forced necessarily to do that. Like kind of questions for us can also be quite speculative things that just help us probe certain areas. They don't have to be precisely formulated or even approached in the way that I think you would have to with a science methodology. But so for me, when I think that often when I pose questions with a project I'm working on now, and often the project itself doesn't even get close to answering them. It's more like I kind of maybe start answering the next project or the next, So I find defining questions a kind of like driving force that's really useful. And I think that, there are some people that do design research or arts research that are very comfortable in that kind of speculative space. But I find it, I find it more, I don't want to say just more productive. Maybe it's also because I've always been pushing to work in interdisciplinary ways. Like almost all my projects have had some kind of either collaboration or consultancy with some other technical expert group, whether it's technology or biological sciences. And so it's helpful just to have those conversations with people, is to frame questions, and where can you agree, do you disagree? But I think because arts research is not, I would say it's not so accepted as a type of research. We're used to thinking of like science methodologies, maybe the humanities, but to get a PhD in the arts is still a relatively new thing. And so because our field is quite new, I maybe feel a bit more pressure to think about methodology and questions in a way that you don't have to in the arts. Like, I think we're still trying to come up with the language and the practices that maybe mean that we don't have to kind of assimilate with other fields as much, and we can kind of try to conceive of what arts research is alone, independently. But maybe, I don't feel like we're there yet. So.
But I believe that it also raises like critical thinking towards your own work. So the reason I ask that, because I believe this is very useful for the students when they start a project and have them question where is this going to take them, and also like the question you were asking about, what you were saying about how artificial intelligence, all these algorithms that it's taking over in the future. It's going to be our normal practice, and we don't realize, we don't know. So can visualization make the human come closer to? I think that's like a really, really interesting question that you're raising about your work.
Yeah.
I have two questions. The first one, for the machine learning, the visualization that you used, did you link it with a certain like a machine learning software that analyzes basically when there are like mistakes or bugs, and then when the machine is doing what it's basically supposed to do, or is it like how do you determine that? Yeah.
Yeah, so the workflow for that project was I started out in processing in a very common library. It's the scikit-learn library.
What's it called?
It's called scikit-learn, like SCI and then kit-learn. And so it's a really accessible library for starting out. And and the output of the classifier in that case is what's called a dot file, which is, it's kind of like written in syntax, but there's a kind of structure to it. So I took that dot file, and then that's what I used, I rebuilt the dot file in Unity to create this visualization. So you can imagine, as a very simple algorithmic process, it's a visualization of a series of if-else statements, right, where the data gets divided according to its value.
I see.
And And so in regards to the mistakes, what happens is you train the classifier with a particular data set that's called like your training data. And so then the classifier emerges from that training data. And then you use another data set that the classifier hasn't seen, and then you pass that through the same algorithm. But that data set does have its what you'd call its targets. So for instance, with the iris dataset, it's a really famous dataset for kind of starting out with say this kind of system, and it's just classifying is it an iris, which species of iris flower is it? And I think there's 3 options, right? And it's based on the features of the dataset would be measuring the petal length of the flower, and then the petal width, and then the sepal length and the sepal width, things like this. And then the algorithm learns to decide, oh yeah, these measurements correspond to this kind of species, right?
Okay.
And so what I mean is the data sets contain the data that says, yes, it's this species, right? So in the real world, that wouldn't happen because you're using the algorithm to predict that answer. So that's how I can visualize the mistakes, because you're passing data through the algorithm that the algorithm hasn't seen, but it does have those predictions attached. So you can see, it made a mistake.
I see. So it's based off of it's analyzing actual visual data, like the petals and the length.
That's what that was. So that was the first one, but then the others are just like synthetic data. I just generated the data just for the sake of creating a different shape of tree, for example.
I also have another question. Have you, or is there any way you recommend like applying it to things like messenger bot, or like analyzing customer data, things like that? More in the like customer data or.
So I think that I could imagine decision trees being used to analyze customer data. So one data set I experimented with was data that came from a bank, and it was deciding whether a person could have a bank account, I think, or not. And the reason I wanted to look at it was because it was like, okay, this has social consequences, right?
Yeah.
People, depending on where you live or how old you are or what your job is, whether you're allowed a bank account, or maybe it was a credit card account or something. So for instance, I know decision trees are used in that area, but something like Twitter bots, I think it's a different type of machine learning. So I said, this machine learning I started with is the most simple type, and then you just kind of build up. And so when you hear about things like convolutional neural networks, this is like a much more advanced type of machine learning, where they're really struggling to answer quite basic questions like, why did it make this decision? Or if it made a mistake, we don't quite know how it made that mistake. And that's, I hope to work in that area, but with this lab, this computer science lab, where I don't have to be the kind of engineer of the system. Like, I want to be able to work with algorithms that are already developed, and that I can kind of just use my skills to sort of think about these more broader questions like ethics and how to visualize contention. But when I talk to computer scientists that work in machine learning, they'll often say things like, sometimes we have this data, we're trying to kind of predict, and we'll try it out on a decision tree, then we try it out on this other neural network, then we try it on, and it's almost like whichever one fits better. I always imagined that there'd be a very precise science too, but it seems that it's a kind of, I don't say an art form, but there's a lot of scope for.
You have to test.
Yeah, it's an empirical science in a way.
Thank you for answering that question.
When you generate the form cell part,
Yeah.
I found the design was surprising because it's a very unique design, and I kind of want to know more how you were able to bring that out from like this picture of cells.
So I started with a 3D model of the molecule, and the workflow was like, it was done in processing, and I created a lot of agents that would kind of crawl across the geometry of the cell. And I generated this, I said like the depth pass and the ambient occlusion pass, just to create different aesthetics, so the agents had some other data that they could relate to. So with that particular project, even though it was for a design competition that was a kind of a type of science visualization, I approached that very speculatively. So I imagine that someone in the medical profession probably not finding that visualization useful, but I was trying to just come up with like a different aesthetic for the whole thing to what I'd seen.
One can think about how those different kind of pixel values could translate to analyzing the actual scan of the cell itself.
Maybe, yeah. I mean, if I did something like that now, I'd probably approach it a bit more practically. But I really just wanted to. I was really new to processing at that point, and I really just wanted to kind of play with agents and kind of create nice aesthetics.
I have a question. Thank you for the lecture. It was really fascinating. But the part that the algorithm like recognizes the moving objects, and then like you like got the reference of like surveillance video, and getting the people like just like walking, and that, and also like the chameleon video, the video of the chameleon. So are those like method are they used for like some sort of like animation? Like I was thinking about Lord of the Ring, the one of the what's the character name, the monster or whatever. But
Is that from a film?
The Lord of the Ring.
Oh, the Lord of the Rings, right?
The little creature, very ugly creature, like it's gone, yeah. But they have these like spots.
Oh,
and
right, like motion capture.
The motion capture.
Yeah.
So
I don't know a lot about motion capture.
But I mean, they are also about matching.
Yeah, it is. Yeah. So I think motion capture is situated within the like computer vision field. But I'm trying to think how that would be related to what I was doing.
but the thing is sort of different, like it's the one
So
that
with that technology, like I only know a bit about it. We actually have a lab at USC that does that, and I've seen them kind of capture like the performers moving around. So they create these different points, right, on the body or the face that kind of are like measuring movement.
Okay.
And then somehow they use that to kind of like sync it with the model, the CG models of the characters. So in this case, all the algorithm is doing is detecting, is the pixel of the image, like the video of the chameleon, is it changing over time, each frame? Is it changing or is it static? And then, so I was really interested in the fact that that's a really simple computation. Is it a changing pixel or is it a static pixel? And then in the first video, it's just drawing a little square around that pixel to say like, oh, this detection. And then in the other video, it's printing the colors of that pixel back to the screen over a black background. And so I would say it's doing something like much more simple and to sort of motion capture.
But you brought up Photoshop and how you take a lot of these algorithms for granted, and talking about this idea of referencing. And if we think about After Effects pretty much as Photoshop with a timeline, similar algorithms are currently applied to the way that you could assign an object that could follow a moving image. So you can have a background video and you can assign things that are being traced over. So it's using, again, the logic of tracing or looking at pixel difference.
It is, right.
Thank you.
Wow, that's great.
I was wondering if you could talk about something that's very important as part of the PhD practice, which is rooted in this idea of balancing theory and practice. most of students here in a program like this, they're extremely capable of technical skills, and what becomes often very difficult in this field is to be able to write about the projects, and often what you're faced with, and this was something that we had to kind of unpack in a senior course, which was dedicated to putting a portfolio together. So because often this part of practice is quite kind of separated from writing about the work itself, then it becomes very difficult to 4 years on to go back and write about some of the projects. Now, one thing that's very important to the type of PhD that we're in, is the fact that for us, the theory and practice are two parallel streams that we're encouraged to develop together, and often where they meet is the writing component. That the way that, in a sense, it's described to us usually is the fact that you don't want to wear two hats, which is one is the practice hat, the theory hat. You want to be able to constantly go between that. So I was wondering if you can elaborate on that a little bit in terms of how you think your writing has helped you in developing some of these questions that Anna was emphasizing. If you feel that your research methodology has changed, then how has that kind of helped you in taking learnings from one project and carrying it on to others?
I think that, like you say, it is difficult when you have to do both tracks. You have to develop design research, and then you're also expected to write theoretically and kind of keep up with that. And yet, often for us at least, the theoretical side is often coming from a slightly different discipline, whether it's the digital humanities or sometimes the social sciences, like communication. Or, I think first of all, I really appreciate being able to connect to different disciplines. And one of the things that I've always really loved about media arts is that it's kind of it's a field that's sort of already sitting between a few others. And so for me, that ability to more easily connect with other fields and to have discourse with them is like one way for me of starting off. But then, like the most obvious way that I would carry out this kind of practice theoretical work is like, you develop a project and then you write a paper about it, and that's one way of like publishing a paper, is to develop a project and kind of write around the some of the contextual issues. So for me, I will, like for example, working with this machine learning algorithm, like the actual project I'm doing, the actual work I'm doing is not really addressing some of my interests in the project yet. I haven't got it to that level yet, but I'm thinking around how this could be situated. I'm thinking about like some of the questions or the problems that come out both in like not popular media, but kind of I follow things like, say, ProPublica is a online publication that often looking at some of these issues. So I'll follow literature like that, and I will situate my work in a much broader social context, or it could just be an artistic context. But for me, it's often like a social, political context. And I'm interested in how the work I'm doing could ultimately not even impact, but just be part of a discourse that's more broad. So that I think that's one way I will do that. And is that what you meant?
Yeah.
I think there's other ways of doing it. Did you mean just practically though, as in like you do a project and then you have to write about it much later? And
So which is usually the way that you kind of address it in
Yeah.
undergrad courses. We have an exhibition end of the year. We need to put a text together. You need to put a website together, which is I think something that we often suffer.
I mean, I think that you should just have a website already, and you know, I would really, if you haven't got a website, you encourage you to have one now. Like, don't wait till you're a professional, but to have one now, and every single project you do, you upload it, so people can see your work and maybe invite you to things. So then when it comes to having to go back, return to a project at a later date, you've already got kind of a contextualization of that project on your website. That's what I would do. Is that, and the motivation is not necessarily to do the writing. The motivation is that because you want to present the project out, you want to put it out there.
Any other questions?
So in terms of when you actually start the project, is how much of it do you have visualizing from beginning to end? And when you visualize it in your head and when you actually start, how much of it is art to you and how much of it is just data?
So the way I work is, so I definitely don't know how it's going to turn out. And especially because some of the techniques I work with have this emergent quality to them. So a lot of it comes from a lot of iteration in a typical design research sense, iterating through lots of different versions of something. And so I usually start out with some vague idea like visualizing algorithms, and I'm like, I don't know how I'm going to start this, but so I don't know if that's personal, but I'll start out with something that I don't know how to do, but I know it's interesting to me, and I think to, you know, in terms of the context I'm working in. I know it's kind of, often I'll like come up with an idea that I know it's like kind of contentious, but I know that there is a visualization possibility in there. And then what was the second thing you asked me?
Basically, like, how much of it is now?
Oh, yeah. That's interesting, because I think that's something I kind of battle with a little bit, in that, because ultimately what I'm trying to do is use the knowledge we develop in the arts to address what I think is more important, like the big issues or contentious issues in the world, right? And sometimes I guess I felt like coming from the arts, sometimes we don't do that, like especially in the visual arts, like, and so that's why I find myself sort of slightly pushing up against these other fields. And when you do that, especially I think coming from the arts, you have to be the one that constantly reaches out, that constantly like learns that field's vocabulary and what problems they're dealing with and how you can somehow insert yourself into that project research group. And, you know, I feel like I have to do all of that work, whereas these other disciplines, when I feel much more kind of stable and kind of secure in their fields. And so it's a difficult path, because sometimes I've had the problem of working with scientists, and that scientists, at some point it's become obvious that they think you're there to kind of serve their interests, you know, their work research. And it's just difficult. You've got to kind of like play that path, because that's not what I'm trying to do. I'm not trying to assimilate with another discipline and assimilate with their methodologies. I'm actually just trying to learn enough so that I can collaborate. But knowing that they're not going to learn about my field, I have to do the work in sort of translating. And so for me, with this latest thing I worked with, I had to work out all sorts of little details about how this classifier works and sort of what the code looks like, just because I want to collaborate. But really, what I'm really asking for now is, okay, let's work, like, you give me your algorithms and your data, and let's work on this more collaboratively. I don't want to, I'm not an engineer, and I'm not trying to be. Sometimes you have to do a bit of that work in a simple way, I find. So.
And I think that's key because that's something that really, I think it's a common thread or conversation among, especially our group at USC, which we just need to have some work or a research that, in the sense of scientists would trust us enough for us to allow us to collaborate with, and that's it often takes time to be able to generate enough content just to be able to get ourselves through the door and be able to even be part of their labs. But I think that's the fascinating thing about this introducing the research. That's just because you want to collaborate with them doesn't mean that they are interested. So being able to maneuver how much you want to give into that aspect, how much do you want to spend time kind of assimilating to just different paths, that's also a very fascinating way of balancing our resources and our time.
Yeah, I feel like for us in media, the way we work in media arts, it feels like there's this unlimited opportunity of freedom in like where you want to work and how you want to work, but that freedom just has challenges that come with it. So it's like, and as long as you kind of are comfortable with that, with the freedom comes quite a lot of challenges.
And on that note, we want to really thank you for sharing your work with us and great conversations, and really hoping that students will take away from this conversation and be able to incorporate that in their work, especially because we have a few of them that next week they're going to delve into data visualization. So this was inspiring. Thank you very much.
Thank you.